Good morning, children. We proceed with exercise 2.8. Today we are going to learn polar form, how it is used in solving complex equations. Z is a complex number and we have equal to 0. Some equation is this. So we are going to apply polar form and solving such equations. Very first step, z cube I can rewrite minus 27. Z is equal to minus 27 the whole power 1 by 3, which can be rewritten as 27 power 1 by 3 minus 1 power 1 by 3. In the previous classes, we have learned certain polar form to be remembered. Minus 1, I will write cos pi plus I sin pi. Plus 1 means cos 0 plus I sin 0. Minus 1, we have to remember it is cos pi plus I sin pi. The whole power 1 by 3. 27 power 1 by 3. 27 can be written as 3 cube. 3 and 3 will get cancelled. Keep this 3 as it is till the last step. So my very first step is write the polar form. Second step, add 2k pi to the argument. Cos 2k pi plus I sin 2k pi plus pi. So what is the second step? To the argument we are adding 2k pi. Third step, the power we have to bring it near the argument. That is, we are applying de Moivre's theorem. Let us remember, de Moivre's theorem tells the power whenever it is positive integer, negative integer or fraction, say rational number, it can be brought to the argument. So I will rewrite this as cos 2k pi plus pi by 3 plus I sin 2k pi plus pi by 3. So the power is brought to the argument using de Moivre's theorem. And once I apply the power, I have to immediately write what is k. K is 0, 1, 2. How do I write it? In the given question, it is 1 by 3, the power. The denominator decides k value. Denominator 3 means I should get 3 roots. That is k value 0, 1, 2. Now wherever k comes, if you want, you can substitute and simplify or leave the answer like this, and this is the solution. Question number 10. Prove that the values of fourth roots of minus 1 or plus or minus 1 by root 2 into 1 plus or minus I. So let us proceed in the same format like the previous problem. First of all, it is minus 1. How to write the polar form? Cos pi plus I sin pi. First step. What is the second step? Add 2k pi to the argument. 2k pi plus I sin 2k pi plus pi. The third step, raise it to the power 1 by 4. Fourth roots means the whole power 1 by 4. So cos 2k pi plus I sin 2k pi plus the whole power 1 by 4. Applying de Moivre's theorem. What does the theorem say? Bring the power near the argument. So cos 1 by 4 2k pi plus I sin 1 by 4 2k pi plus pi. Wherever k is coming, the values will be 0, 1, 2, 3. Denominator 4, stop with the previous number. So I must write 4 roots. 0, 1, 2, 3. In the previous problem, we stopped the answer with this. But here, they have asked it. So we need to prove the answer. Wherever k comes, put 0, 1, 2, 3 and find the answers. So first thing, k0. What I get? Cos, I am putting 0 here means 0 plus pi, that is pi by 4 plus I sine pi by 4. Put k value 1. Cos, putting 1 here, it is 2 pi plus pi, 3 pi by 4 plus I sine 3 pi by 4. Next I put k value 2. So k value 2 means cos 2 into 2 pi, 4 pi plus pi, that is 5 pi by 4 plus I sine 5 pi by 4. Then put k value 3. 3 into 2 pi, 6 pi plus pi, that is 7 pi by 4 plus I sine 7 pi by 4. Please check that it is proceeding in the same format. See, pi to 3 pi by 4. How much is the difference? 2 pi. Same idea. 3 pi by 4 to 5 pi by 4. So, every time 2 pi by 4 is increasing. Here also. 5 pi by 4 to 7 pi by 4. So, the difference must be same. Let us remember. It's a very important concept. Simplifying this answer. What is cos pi by 4? We have to remember from the table cos under pi by 4. Cos under pi by 4, it is 1 by root 2. Sin pi by 4 also 1 by root 2 only. So it is 1 by root 2 plus I into 1 by root 2. First answer. Or I can say 1 by root 2 common into 1 plus I to bring about the question's expected value. Second, 3 pi by 4 will be written as pi minus pi by 4. So let us work out these things here. 3 pi by 4 means pi minus pi by 4. Which quadrant? Second quadrant. Similarly, 5 pi by 4 means it is pi plus pi by 4. This is third quadrant. 7 pi by 4 means it is, how will you write it? 2 pi minus pi by 4, or this is fourth quadrant. So, the given question, very first idea is first quadrant, both are positive. When I am in second quadrant, cos negative, sin positive. So this is minus 1 by root 2, whereas this is plus 1 by root 2 only. Take 1 by root 2 common, it is minus 1 plus I. The third part of the question, 5 pi by 4. Where are we now? In third quadrant. Third quadrant, both are negative. Cos is negative, sin is also negative. So, minus 1 by root 2 minus I into 1 by root 2. Taking 1 by root 2 common, it is minus 1 minus I. Or, if I take minus sign outside, it is plus 1 plus I. And 7 pi by 4 is fourth quadrant where cos is positive but sin is negative. Taking 1 by root 2 out, it is 1 minus I. To write this also in the same pattern, if I need, I can bring minus out. It will be plus 1 minus I. Now, combining the four answers, it is either 1 by root 2 or minus 1 by root 2. It is either 1 plus I or 1 minus I. So, combining all the four, I write it is plus or minus 1 by root 2. 1 either plus or minus I, and that is the value for the given problem. So, given minus 1, let us remember polar form is cos pi plus I sin pi. Second step, add 2k pi. Third step, power comes near. Put k value 0, 1, 2, 3. That is for 4, the previous number. Apply the value since they have asked some result. And remember, First quadrant, both are positive. Second quadrant, cos negative, sin positive. Third quadrant, both are negative. Fourth quadrant, cos positive, sin negative. Combining all the four values, we arrive at the expected result. Question number 3. Find the value of 1 plus sin pi by 10 plus I cos pi by 10 by 1 plus sin pi by 10 minus I cos pi by 10 the whole power 10. Now this problem has the numerator and denominator a slight difference. Here it is sin plus I cos and here it is sin minus I cos. So let me take z is equal to sin pi by 10 plus I cos pi by 10. Then what about z bar, which is nothing but the denominator. It is sin pi by 10 minus I cos pi by 10. How will I write z bar as? Z into z bar is equal to sin square plus cos square. Sin square plus cos square is 1 means z bar I can write 1 by z. So this is nothing but 1 by z. Putting it back in the question. 1 plus sin pi by 10 plus I cos pi by 10 by 1 plus sin pi by 10 minus I cos pi by 10 the whole power 10. We just replace 1 plus this idea we have taken z. So the denominator becomes 1 by z the whole power 10, which becomes 1 plus z by, for the denominator z is the LCM, cross multiply, it is z plus 1 and it is the whole power 10. 1 plus z I can cancel. It is denominator's denominator reciprocate. I get z power 10. Now what is z actually? Z is nothing but sin pi by 10 plus I cos pi by 10. So z power 10 is sin pi by 10 plus I cos pi by 10 the whole power 10. Can I bring 10 near? By applying de Moivre's theorem, many of us may think yes, but the answer is no. I can bring the power in provided de Moivre's theorem's application is only for cos plus I sin. Whenever it is cos plus I sin, I can bring it near. Cos n theta plus I sin n theta. So that is de Moivre's theorem. But in this question, I am having sin pi by 10. What shall I do? When I want only cos, take I out. So I will rewrite this as I power 10. I am taking I out. It is I power 10. I comes out with this power. What is left out? Cos pi by 10. This will be, when I am taking I, it will be 1 by I sin pi by 10. Remember, whenever we take something out, every term must be divided by that. And what about this 1 by I? This 1 by I is nothing but minus I. Very first class we have learnt about it. 1 by I is nothing but minus I. Now this is cos theta plus I sin theta. So I can very well bring 10 inside. So this becomes, what is I power 10? Let us recall. I power multiple of 4 is plus 1. I power even but not multiple of 4. So I will simply write minus 1. And bringing power inside, it is cos 10 pi by 10 minus I sin 10 pi by 10. 10 and 10 gets cancelled. Sin pi 0, whereas cos pi is minus 1. So minus 1 into minus 1, my answer will be plus 1. So the given problem, the answer reduces to be plus 1. So today we have done 3 different problems. with 3 different models. Learn each problem with more concentration and understand the depth of it. Thank you.